Hello, geometry students. Welcome to the hardest easy lesson in geometry for the year. Now, what do I mean by that? In this lesson, we're going to be talking about truth tables. What is a truth table? It's a table that lists all possible combinations of truth values for a hypothesis, conclusion, and conditional statement or conditional statements. So when I talk about conditional statement, remember if, then, if, then. When I talk about other statements, I'm talking about the converse, the inverse, the contrapositive. We're going to learn about another one today, a biconditional statement. Okay? A truth table is going to tell us what the possible combinations of true and false are for different statements. Now, before we get into this, I just want to point out, I said this is an easy hard lesson. It's easy because it's formulaic, okay? These tables always look the same. It's hard because your brain doesn't like that. Your brain is going to try to overcomplicate things. What you're going to try to do with this lesson is you are going to try, your brain wants to, okay, if you can override your brain on this, but what your brain wants to do is read an individual problem and then adjust each individual truth table that you make based on that problem. So what you're going to try to do, oh, this problem talks about if x is greater than or equal to 2, then x squared must be greater than or equal to 4. I need to write my truth table specifically based on x values. No, your truth table always looks the same. Your truth table always looks the same. And then you use your truth table as a guide to figure things out about this individual problem. So the truth tables don't change to an extent. Now, let me clarify a bit. You can put more columns in your truth table or fewer columns. For example, if you know you're going to be dealing with the converse of a statement, you should put a converse column on your truth table. You don't have to have a converse column on every truth table, but if you know you're going to be dealing with a converse, put in a converse column or an inverse column or a contrapositive column. Okay, so different truth tables may have different columns, but every single time you put those columns in, they always look exactly the same. Let's take a look at a sample truth table to see what I'm talking about here. All right. Oh wait, this is the wrong type of truth table. Let me get rid of that. All right, here we go. This is what a truth table looks like. So notice that I have a hypothesis, a conclusion, and a statement, and these are always going to look the same. Down below, I could have a true hypothesis with a true conclusion, a true hypothesis with a false conclusion. That one's special. Notice it's highlighted in blue. A false hypothesis with a true conclusion, or a false hypothesis with a false conclusion. All four of these are possibilities, and these are the only four possibilities of combinations of true and false between my hypothesis and conclusion, or statement P and statement Q. Now, I want you to think about this for a minute. If my hypothesis is true in my statement and my conclusion is true, I have a true conditional statement. This special row, if my hypothesis is true, that would be like that one problem we ran into. If a bird is a swan, then it is white. Okay? If I find a bird that's a swan, my hypothesis is true. But if it's black, a black swan, my conclusion is not true. What did I just find? I found a counterexample. This blue highlighted row is the counterexample row, and it's the only row that can prove a statement false. Notice the truth values for all the other combinations are true, and this is the only one that's false. So what a truth table really does is it lets you analyze a situation that you're looking at and determine how you're going to prove whether the statement is true or prove it false. Okay, what are the conditions required to prove a statement false? Well, I have to have a true hypothesis and a true conclusion. And if I have a specific situation written up here in my truth table, then I know what I have to do exactly to try to prove a statement false. That's where the truth table's value really lies, in just helping you analyze different types of logic problems. All right, before we move on, let's talk about what happens if your hypothesis is false. So I had my statement that I just stated. If a bird is a swan, then it is white. Well, what if instead of finding a bird that's a swan, I found a dog, and the dog was not white. If a bird is a swan, I don't have a bird that's a swan to examine. I have something different instead, like a dog. I can't make a conclusion. So even if my conclusion is true, that dog is white, okay, I can't prove anything about swans. So therefore, if my hypothesis is false, I can't really make a judgment on the truth value being false. So we just say the truth value is still true until you disprove it. And that's what these two are. The two hypotheses false, it doesn't matter what the conclusion is. If the hypothesis is false, if I don't find a true example of what it is I'm examining, I can't make a statement that the conclusion is false. So the conclusion just defaults to still being true until I can disprove it with a counterexample. So I hope that makes sense. We're going to be looking at some specific examples of this in just a moment.